Good morning, good afternoon, good evening. Welcome to the Syntergy webinar series. My name is Vijay Sharma, and I'm the VP of Sales and Business Development. And joining me on this webinar today will be Sasha Dimitru, who is one of our product specialists with expertise in our synchronization technologies. Before we get started, this webinar will be recorded, and after the session, we will distribute the recording via our website so that you have a record of it. And for those folks who could not join today, again, and then another bit of housekeeping: if there's any questions that come up, there is a chat window at the bottom of your screen there, and you can type in your questions there, and one of my colleagues will answer the questions as we go along. And if we don't get to all the questions, we'll have some time at the end, and we'll answer the questions right at the end if we don't have time to answer all of them. But feel free to type in your questions as we go along. So let's get started. So let's get started. So in this webinar, you will learn how Syntergy's always-on content server solution will help you implement a metro-level continuity of operation strategy, availability during planned and unplanned outages as much lower cost than traditional synchronization replication options. As you know, designing a hot backup or failover solution for content server presents unique challenges. This webinar will look at these challenges, demonstrate the capabilities of Syntergy's always-on content server solution, and show you how Syntergy can simplify your life as an administrator. As you know, digital transformation is no longer a nice-to-have conversation. It is a must-have reality. OpenText customers are transforming their organizations at a rapid rate to more digitally ingrained organizations. And as a result, organizations have come to expect a 24/7 access to their data and applications. So downtime is no longer an option and in the event of planned and unplanned outages. We will discuss how an alternate strategy, such as an application-level data replication, offers a fast and cost-effective way to get OpenText content server back up after a major data loss or a service disruption on your primary system. The agenda for today is we're going to start off by just kind of looking at a little bit of the high-level differences between what is high availability, what is disaster recovery versus fault tolerance infrastructures. We'll review a little bit about what you typically see in a service level agreement with the business. This is more IT-focused service level agreement, so the concept of a recovery point objective, a recovery time objective. We'll touch a little bit on the limitations of active-passive disaster recovery solutions in relationship with the content server architecture, the multi-tiered architecture. You probably have all of those kind of implemented, or some of them. We'll talk a little bit about that, and then we're going to jump into the Syntergy's always-on content server solution. Give you a little bit of an overview of what it is, and then my colleague Sasha Dimitru will jump into a demo. It'll be a high-level demo, and if there's further interest, we can always schedule a more detailed demo with you. So let's get started. For those of you who don't know Syntergy, we have been in the OpenText ecosystem for over 20 years, headquartered in San Diego, California. And we are an OpenText technology partner with over 20 content suite products. And our mission really is to enhance the use and performance of your content suite platform, both from a performance as well as a security perspective. Some of the popular technology solutions. Today we're going to focus on the one that's highlighted in red, the always-on content server for high availability and disaster recovery. But some of the new things we're doing is we also have a solution in the data loss prevention space for your Content Suite platform, as well as the capability to synchronize content to major cloud services out there, such as OneDrive, Box, Google, Dropbox, etc. So let's just kind of touch a little bit about this question comes up a lot. Where do we fit in? And just a kind of quick review of what these three segments are. Some of you probably have all of them implemented. Most we see are more in the disaster recovery space in terms of your implementation for a DR strategy, or a combination of fault tolerance and disaster recovery. So high availability is the concept or goal ensuring that your critical systems are always functioning. In practice, this means creating and managing the ability to automatically fail over to a secondary system if the primary system goes down for any reason, as well as eliminating all single points of failure from your infrastructure. Like disaster recovery, high availability is a strategy that requires careful planning and use of tools. So why is this important to have a well thought out high availability architecture? Because the cost of downtime is high, whether we're talking about dollar figures, the lost productivity of your staff resorting to manual processes, or the impact of mission critical applications on your business when your system is offline. Disaster recovery refers to a set of policies and procedures in place to ensure that the continuity and recovery of mission critical systems in the event of a disruptive event such as a power outage, flood, or a cyber attack. In other words, how quickly can you get your computers and systems up and running after a disastrous event? And then finally, fault tolerance really describes as a computer system or technology infrastructure that is designed in such a way that when one component fails, whether it's hardware or software, a backup component takes over operations immediately, so there's no loss of service. The concept of having backup components in place is called redundancy, and more backup components you have in your place, the more tolerant is your infrastructure. So just a sort of quick review of these three segments, and we'll kind of talk about where we complement these three different segments. Interesting quote from Forrester. I won't read it all, but the last bit, the last paragraphs kind of catches my attention. Organizations must evolve beyond reactive business continuity and IT disaster recovery. So meaning, today we have, you might have a good DR strategy, whether it's backups, offsite backups, or a mirroring technology, whether it's SQL log shipping, or it could even be always on content, SQL servers, etc. But the interesting part is that that most of those solutions are reactive, and the cost as per core site is anything between $5,000 to $10,000 per minute when your mission critical applications are down, whether it's planned or unplanned systems. So just a couple of things before, just to review what is a you'll hear these terms: recovery time objective, or common acronym meaning RTO. A recovery time objective is the duration of time and service level within which a business process must be restored after a disaster or disruption in order to avoid unacceptable consequences associated with the break in business continuity. So it's essentially from the time of the disaster to that window, whether it's 4 hours, whether it's 24 hours, etc. And in reverse, the term RPO, or recovery point objective, it looks backwards. It's defined by the business continuity planning organization, and it is the maximum tolerable period in which data might be lost from an IT service due to a major incident. The RPO gives systems designers a limit to work. For example, if the RPO is set to 4 hours, then in practice, offsite mirrored backups must be continuously maintained. A daily offsite backup on tape will not suffice. So, typically if you're doing, a daily backup, that's a 24-hour window. So that's not going to meet your RPO requirements in terms of how much data loss you can live with. And as you know, disruptions can be planned and expected. There could be many reasons. We always think about natural disasters such as storms, water damage, fire, power outages. However, disruptions can be planned and expected. There could be building maintenance, there could be an infrastructure maintenance on your systems, content server updates, upgrades, etc. And again, these all impact your businesses. And again, if you're a system administrator or involved at the technology level, you'll realize that recovery is costly. According to data from Forrester, the average recovery time is over 18 hours from the time, let's say if you're relying on backups, whether it's SQL log shipping, whether it's mirroring, the amount by the time you restore, you rebuild, reindex, etc. That could take you a while. And then the interesting statistics is that less than 50% of the organization perform a DR test, or they'll perform a DR test once a year, and almost 20 to 25% of organizations don't even do that because it's impractical to do that in your environment. And then again, if there's an outage, it's a disruption to your business from your resources. Technical resources are being shifted to the outage versus focusing on their daily tasks. Some of the solutions I've kind of highlighted here. There's many ways to do this. Anything from straight, simple backups on a daily basis, whether it's incremental, full backups. The active passive DR solutions. You've probably got the most common ones we see are mirroring, whether it's SQL log shipping and then copying of your content server, external file systems, or some companies even have set up, the what we talked about, the fault tolerance systems in terms of their infrastructure. But the one thing to bear in mind is that industry experts continue to recommend the traditional out-of-the-box methods, or what I like to call active passive solutions, which are either Windows Server or database based, example, Oracle SQL database based, and not content server based. And there are limitations with these approaches, and they're not meeting most organizations' service level agreements. As content server external file system needs to be replicated separately to the DR location, impacting RPO. So if you've got a SQL log shipping scenario set up, but you've got to then copy the EFS as well, and they might not be in sync, and that will impact the your RPO, so how much data loss you're willing to live with. So that's something to consider. In our opinion, VM replication is the best approach we see out there. But again, there are limitations, especially if you're restoring to the same server. These configurations are best served when very close in geography to your production content server. That is, if you clone a VM, it needs to have the same network configurations, etc. So just wanted to kind of highlight some of the what we see out there. They work, but it's not that they don't work, but that impacts your RPO, that how much data loss you're willing to live with, and also your RTO in terms of how long it will take you to recover from it. As you know, content server has a complex multi-tiered architecture. You've got web front ends, databases, external file systems, search indexes, index servers, admin servers, archive servers, depending on your setup. And content server operates at distinct layers, each of with their own operational requirements. When planning, what we recommend to our customers, when planning for DR HR strategy, our recommendations would be to have a redundancy built in your production system as a first line of defense. So example, multiple web front ends, RAID systems, also a redundant database as part of the architecture where you can have 2 SQL servers, for example, and multiple web front ends already and waiting to be used in case of a layer fails. Because of these limitations inherent in content server high availability options for you, IT departments are now demanding and implementing application layer replication technologies such as Syntergy's always-on content server to achieve the SLAs in terms of your RPO, RTO. And the goal here is to provide a technology that will give you a highly available content server that you can fail over. And we'll look at some of that in a minute. So just to kind of give you a pictorial view of what's out there, and you've probably got either all of it implemented or you've got some of it. On the bottom left is the cheapest solution, and we always recommend you have that in place, your backups, offsite backups, and that's your last resort if everything, if you need to restore if anything goes wrong. That's your cheapest option, but that is also your highest RPO and RTO in terms of how long it's going to take you to recover and how much data loss you're going to have. So typically on a typical backup solution, you look at 24 hours of data loss. And then as you move up the ladder, there is different asynchronous replication setups. And then the best out there would be your classic synchronous replication. So again, these, there's a cost associated with that. So, with synchronous replication, you got more cost, but again, you reduce your RPO and RTO. With Syntergy's always-on content server, you can achieve the functionality of the synchronous replication at a fraction of the cost. So essentially the bubble at the top right, we can play in that space at a fraction of the cost what it would take you to put in a synchronous replication technology, as well as give you all the flexibilities that we'll talk about in a minute. So your decision factors really come down to, it's again going to be down to your company's service level agreement, what's been agreed with the business. It's whether it's, and the left-hand column is typically your classic disaster recovery solutions, such as SQL log shipping with external file system copying, or you could have just your typical backups and restores. And these things typically are higher in the RPO, RTO numbers. The process is manual and very involved. Even if you've got automated scripts written, there's always an issue, we find. Homogeneous setups, and your system is down during recovery. So if it's going to take you 24 hours to recover, your system is down, right? And typically these systems must be identical as well in infrastructures. The right-hand column will give you what we offer as a with Syntergy's always-on content server. Your typical RPO times, depending on how much volume of data you're ingesting into content server on a regular basis, will be from minutes to close to zero. The process is light to automatic, depending how you set up your failover, and you can have a heterogeneous setup so that you don't have to have if you've got a very high, you've got a powerful production infrastructure. You can have a subset of that infrastructure as your DR environment. You don't have to have it identical, and it's always live. So that's the biggest benefit. Some of the other flexibilities you get is that you can have it as identical, or you can have a subset of your content server that is in that state. So certain mission critical libraries that might be related to legal, finance, HR, etc., versus company picture photos. Okay, so the kind of just jumping into the always-on content server introduction, and before I hand over to my colleague Sasha, what you'll see is when Sasha demonstrates the solution that the replication, it's an application level replication. It will give you the capability. With this strategy, you'll always have a content server in your data center that's live and available for testing purposes or to failover, whether it was a hard outage or it was a planned outage that you might be doing an upgrade. Let's say upgrading from a 10.5 content server 10.5 system to 16.2. The system is synchronous, so you can do read writes to it, and you can also have multiple. Some of our customers have multiple data centers. So let's say if you are a East Coast company, you might have a strategy to have one data center in Denver, and the second data center on the West Coast, just to have a dispersed, in geography in case you had a disaster on the East Coast. So these are all the capabilities that you'll be able to configure. Some of the features that you'll see when Sasha does his demo. You can either do a full instance replication, that meaning, give me everything what my production system's got, or you can be more strategic in terms of, I'm only interested in implementing a business unit replication. So picking certain business units, we see that sometimes. And you can be even more granular in terms of a data scope. So I just want certain kinds of data. You can perform, DR audits, etc. While your production system is running. Let's say some of our customers in the financial services, healthcare, perform quarterly audits on their DR system, and this gives them an easy way to test. And we talked about some of these other areas, read-write DR servers, and again, your system can be heterogeneous. Having always-on content server as your DR or your high availability system, it will always be on, right? So let's say if you've got an instance sitting in Texas, you could have a second instance sitting on the East Coast, and during outages and planned outages, it's always on. Already you can log in, you can fail over users, you can test. It's automated, so you're during your RTO phase, when you're doing a recovery, it's either automatic or very light overhead in terms of getting pointing your users to it, and it's always testable. It's always testable in terms of that doing your DR audits, whether it's quarterly, 6 monthly, annual. It's there. It's not a major exercise, and for the IT department, this is a plus. Because your resources are scarce, and you can achieve this very quickly, whether through automated scripts or manually testing your system on a quarterly basis. And again, you have the capability to have a distributed system over a wide area network. So you don't need a high-speed network. 1 gigabit plus low latency network, you don't need it. You can use your traditional WAN environment, and you've got a system in place. The architecture would look something like this at the very high level. The top row is your production instance. As an example, you've got your front ends, your admin servers. In this environment, they've got an archive server, an index server, an external file storage, and an Oracle database. And then, our solution is installed through the admin pages in Content Server, and then your synchronization is typically you can have a separate server, or you can use one of your admin servers to manage the synchronization. And again, the topology doesn't have to be identical. So in this case, you'll notice we've got 3 front ends on the production, but 2 on the DR, etc. Okay. So just some pictorial views of what I talked about early. Here's what a full instance would look like. Data, metadata, hierarchies, permissions, workflows, etc. Being replicated. Which is in synchronous mode. So your DR piece is read-write. It can be write, so when you do fail over, you can write to it, and then that data comes back to you when your production system's back up again. It will get synchronized back. And then you can also have, some of our customers do this. They might say, I don't want to have the full environment, but there's certain mission critical applications in finance, legal, R&D, etc. that we want to synchronize. And you can also have stop points. So how deep you want to go down in your hierarchy of your folder structure, right? So it's very, very granular how you can set up your high availability DR centers. And again, you can limit the scope. So you might say, I don't want all the audit history there. There's a date range. You can make it read only. You can, if you say, I don't want to take my personal workspaces there. They're optional, workflows, etc. So these are these different scopes that will help you. This question comes up: what objects are supported? So here's a subset of the data I just put up here for. So I'm not going to read through it, but pretty much all the standard stuff that we see with our customers, right? So your documents, folders, and then some of the additional modules such as records management, physical objects, security clearance, contracts. Our new support is for XECM objects. So whether you're using Sept, etc. So we'll support those objects as well. How does it get done in terms of transport? There's no special firewall requirements. It's an HTTP/HTTPS communication. It's flexible how we set it up, depending on what your data. We work with you and look at what your data looks like in terms of whether do you have large files, you have small files, or a mix of both. The transfer file size is configurable so that we are polite on your network in terms of bandwidth usage, and then we can control how often you want to synchronize based on your service level agreement. So it can be immediate, or it can be, you might say, every hour. So we can work with you on that. So Sasha, let's do this. Let's flip over to you, and we're going to jump into the demo.
Okay.
Let me see if I can find you. Okay, I'm going to make you the presenter, and okay, let me know. You should be the presenter now.
Okay, so I'll be sharing my main monitor here. Okay, hello everyone. My name is Sasha Dimitriou. I'm a senior consultant here at Syntergy, and I'll be walking you through a demo of the AlwaysOn product. All right, so just a little bit of background. We have two environments set up here. We have two VMs. One of them is ending in .146. One of them is ending in .133. So this is a Content Server 16.2 environment. I did a little pre-set up here, and as Vijay mentioned, this is it's a module that plugs into one machine within your cluster, so it doesn't have to be any specific machine. Typically, we recommend an admin server, a backend server that doesn't see user traffic, similar to how notifications and whatnot are run on typical, and indexing are run on the administration sides. Typically, we do that. We set up pick a box that would actually act as point-to-point communication from one cluster to the other. All right, so I'm just going to create a folder here, and I will just start setting it up. Demo 01. So add the folder. Now, for demonstration purposes, the synchronization to the DR site is not set up on this folder that I just created. Typically, though, when you have it in the production environment, you have all your data or your in-scope data already set up. And to actually mark your data, it's very, very simple here. Go to the function menu, there'll be a replication section pop up. And the current state is not replicated. So we hit apply, hit full replication, hit apply. And what happens at this point is that the system will now traverse the entire hierarchy. So for this, for this, it's just one object. But typically, you have hundreds of thousands or millions if you click on the enterprise workspace that the system will then traverse and mark. So it's now aware of the system. So the objects. So any changes that occur to any of the objects that are currently being monitored will be sent across. So that includes permission changes, moves, deletes, renames, add versions, all the metadata, RM, that sort of thing. Whatever happens on the object will be sent across and will appear on the DR side. All right, so typically objects. Now if I'll go here right now, and since I created the object, I shall return to content server. Bring me back. I'm going to go into this folder, demo1, and I will create a subfolder right away. So subfolder, and I'll hit add. And if I go into function menu and replication, it'll take us to, again, the dashboard here. And you'll notice the current state of the object, which I just created, is full replication. Any object considers a change. Any new object added to the hierarchy in which it inherits the state of its parent. So the parent has been marked. I added an object within the parent. It is now coming across. So what happens here on the actual application server here on the VM? So we have an export directory and an import directory. So data will be sent out. Any changes that occur on the system will be exported to the DR side. So we have a year, month, day, and an hour folder. If we go into the hour folder, we'll see the information that we just created. So those two folders are in these two packages sent across. So the folders will be created and populated with control files, which will be sent across and then parsed by the DR side and then recreated on the DR system. So we will go there now. So the DR system, similar, we'll go to the import folder. So year, month, the day, and then the hour. And the files come in as part files. So if you have a large data set, we will zip up the object and then we will break up the zip file into smaller pieces that are suitable for the throughput of your network. So certain places, network bandwidth is limited. We can make these zip files or the part files that constitute the zip smaller to avoid network retries or the amount of data that gets sent during a retry rather. All right, so now that the folder actually has the done extension, it's been processed, and if I refresh this page, you'll see a demo01 folder, and if I go inside there, we're going to see the subfolder. So if we just take a look, actually I'm going to set something up right now. I'm going to actually create a document from this side, and we can simulate, we have a failure situation, so the primary system is no longer available. People are starting to use the DR system as their primary system. We're going to go in, we're going to create an object. I will call this from DR01, edit. And the system now, if I hit the function menu and go to replication, the object was just added. It has the state full replication because it, like I said, inherits the permissions from, or not the permissions rather, but the replication state of its parent. So we're going to go up to the demo01 folder here, and we have this verification. So the tool itself has built-in verification and some auditing history in terms of when data was sent across. So, but the verification is probably the most interesting to people who are running the audits and ensuring that the data from the primary system is on the destination system, on the DR system. So we have a bunch of different reports here, but for this one, we're going to run a very, very detailed object-to-object comparison between the source. This is the DR system, the AlwaysOn, and the Content Server 16 system. And it goes through and it compares side by side all the variables or all the parameters that constitute the objects. And the one I wanted to highlight here is the ID value. The ID is the data ID of the object, and you'll notice that the source system and the DR system have the same data ID, so that when the object is in a disaster recovery state. It's on the disaster recovery system. It is the same identifiable object through KID values, or sorry, KUF.ID values, dtree-core.data IDs, and all the unique identifiers that make up the object and allow you to uniquely identify it on the primary system are the same on the DR system. All right, so I'm just going to switch back here. We're going to look at the export directory. So we're on the DR system. So we added an object. So the DR system now will be exporting data to the primary system. And so it's already acknowledged. It creates the folder, creates the zip file, and it sends it across. So if I now go back to the primary system and look in the import folder, again, year, month, day, hour, I expand this out. We see the part files come in, they get reconstituted into a zip, it gets unzipped and then processed. So if I now go back to return to content server and I go to subfolder, there is the DR document from the DR side. So what you're seeing is here 2 content servers in an active state that you can set information from one system and send it across to the other. The data IDs and all the unique identifiers will be the same. All objects and all changes to these objects are automatically picked up and sent from one server to the other. So primary to DR, DR back to primary. So let me just switch up here a little bit. Let's go up one more level. And we showcase a couple other reports here. If we go back to replication, we have our verification, and we'll look at a couple of different reports here that allows us to do child hierarchies, for example. So we can interrogate the child hierarchy of this object 3 levels deep and compare it to the DR system. And this allows you to look very quickly saying, oh, that object's there, that object's there, oh, this one's missing, oh, that one's there. And then so if there's something missing, you can investigate what's going on. Perhaps it's currently in transit, or a confirmation that, yes, the object is there. We have some other ones that are very, very detailed about the versions of objects. Go here, and we can compare the versions of the objects between the source and the destination, or the primary and the always on. So the object number of versions, the file size, the file name, and you'll see if we scroll down, we see like for like. Now, if there are discrepancies, they will be highlighted. You'll see a line across in one of various colors indicating you know, a missing object or a missing parameter or an alternate parameter. So that is the baseline of the demo here. Actually, let me show you one other thing. Let's go to the dashboard here. And this system is useful for system administrators. So this is actually monitoring, real-time monitoring of what's happening in your system. It's currently not much is happening. There he goes. It imported an acknowledgement from the DR system. So acknowledgement came back. So this is, actually, let me send some information across and let's see it. Return to content server. I'm going to go here and send a whole bunch of information. I'm going to go replication, and I'm going to send all this information back again. I'm going to send it all. So there'll be a whole bunch of information, so we'll be able to see it in the dashboard. So again, it's going to traverse the hierarchy, marking all the objects. They're already marked, but basically this is a good way to, for demonstration purposes, load the system. So if you go back to the dashboard now, and we can take a look at the data. So it's going to spool up. I think it refreshes every 15 seconds or so. There we go. So we have import records, export records processed, and the activity queue as data is being processed. We might have missed the activity queue in terms of it picked up right away. If we go back to the export folder, yeah, so it already wrote at the folder before we came here, and now it's basically waiting the 30-second window to send it over to the DR side. We also have some other tabs here that allow administrators to see how well the system is performing. So we have, let's go actually to, yeah, sure, import stats. So we can take a look, and we have a very, very detailed look at the database and the various tables here and how quickly things are occurring, transactions per second, the hit ratio in terms of various objects being sent across, and just allows you to take a look and, if required, tune the database as required. Usually the extent of tuning would be just monitoring the statistics on the various tables and ensuring that they're up to date. Okay, that is I guess the end of this high-level demo. Are there any questions or anything people would like to see, or are curious about its potential functionality?
Yeah, I think Sasha, thank you, and Matt, I don't know if you've managed to answer all the questions, but if you've got any questions that are pending, maybe you might want to open up your unmute yourself and maybe just read them out, and we can just run through those, and then we'll. Thank you, Sasha. Yeah.
Yeah, that's great, Sasha. So there have been a few questions that have come through, and please continue to send them through the chat window or direct to myself. So Sasha, the first one is, do you have to have duplicate hardware and servers in both locations?
So no. So the way the software works is it treats each content server as a siloed environment. So the primary system does not have to look like the destination system. So you can have 3 or 4 front ends. You can have 5 admin servers and archive center on your primary system, but scale back your DR system such that maybe it's only 1 front end, 1 admin server, and no archive center. And it will keep the data in sync because it treats each one as a siloed environment and obeys the rules, the configuration parameters on the individual content server environments. So that allows for diverse setups between primary and DR environments.
Okay. Another one, where does the Syntergy AlwaysOn software need to be installed?
Okay, so it doesn't, it's a module, so it's a content server module, so it would be installed by placing it in the staging directory of one machine in your source cluster, or the primary cluster, one machine in your DR cluster. It doesn't matter which one. It's just a module that installs on an admin server. So now we're talking about degrees of best practice. So the module is a point-to-point communication from one machine in your primary cluster to one machine in your DR. So typically we recommend the module being installed on an admin server on the primary and an admin server on your DR machine, and then we will configure it to talk. Those machines will be point-to-point HTTP, HTTPS communication from one machine to the other.
Okay. All right. Somebody else mentioned that their users are geographically dispersed. They'd like to understand if there's a way to have the same URL for their users, even if they're hitting different clusters.
So the base of the URL, or the meat of the URL, will be the same. So let's just go here. Let's go to here. Well, we can go back here. Data ID of the server's object. So let's go here. Let's just take a look at a more traditional view. Return to content server here. I'll return to content server on that machine as well. So if we go into demo 1 here, and we'll go into the demo 1 folder here, we see the data ID right here, ending in 780. We go back to this one, 780. So everything from the end of the question mark onwards will be the same. I guess the host name and the application name can be variable. We have to have a unique identifier for the host name, and a unique identifier for the host name. This is localhost, but it would be 192.168.1.133. Now, in the event of a DR environment where you actually have to fail over, what you would do is you'd repoint your primary user-friendly name, because these are host names right here, have the actual server names, but you use the application name called, content server, whatever it is in your environment, and you'd have your DNS point to the DR environment rather than pointing to the primary environment. So, you point it to your DR load balancer if you have multiple machines in your DR environment. Otherwise, you have your DNS just remapped to point to your DR machine, and the URL then is exactly the same.
Okay, that's great. All right, another one says, in my organization, we don't want to, hold on, in their organization, they don't want to replicate all of the data, so how do you replicate just a subset for DR purposes?
Okay, so very similar to how the actual demo was conducted. Let me actually go up here and go to Enterprise. And it is a selective process. So you could, in theory, in actually what we did here, let's go to Configure. And you'll notice there's a whole bunch of information here I'm just not displaying on the screen. I'm only displaying the demo folders. And if we go here now, Cancel, and go to the Replication tab at the enterprise level. So this is the enterprise level. So we can pick and choose which objects we want and which structures we want. So we can go into and say, go into assorted data. We want this large file structure, and we want to replicate large file and all its children. In this case, it's one file, but if there were, a whole bunch in a production environment, we could send over just this folder structure, ignoring the data above it. So this allows you to pick and choose the data, the high value data that's worth recovering in a DR. So it allows you to shrink your DR footprint, to again shrink costs, to make sure that it fits into your budget.
Okay. All right, I think we got time for one more here. If users are switched to the DR environment due to an outage, how does the new data get updated once the system is back online?
Okay, so the system is always keeping track of the data, the changes that are occurring. So if an object is sent, or let's actually see what we can do here. Let's go, we're going to turn off content server on the primary system. So we're going to turn off, we're going to simulate an outage. On the DR side, I'm going to go here, I will just go in here and I will create a folder and I will call it outage. Oops. Outage. So the folder is added. So the system will inherit, because this folder was created in a subfolder which is already replicated and comes from the primary side or is already replicated across. We can then, let's look at this first. Replication, inherits the status. So the system will pick it up, pick up the information. Let's go here. There's the activity queue. And what it'll do is it'll start writing out the information to the folder structure here. So this is the folder. It was written out, and that's the control file that contains the information of the folder I just created. It then will zip up the folder and attempt to send it across. So what it does is the system will attempt to communicate to the primary system over and over again until the primary system is online. So we have configurable agents that run, that wake up and attempt to perform work and then go back to sleep. So in the DR environment, the system is set to wake up every 30 seconds, look for a file to send across, and then go back to sleep. So if we go to the delivery logs here, we should see a whole bunch of information here. So here we go, upload file, connection attempt failed. So it will, and these are all the successes from earlier today. So if we go now to content server here, and just say now that we've resumed, content server is now alive and well. So we will now turn on content server on the primary system. My system's a little bit slow here, so it may take a little bit, but the idea is once content server is back online, data will start to flow from the primary system back to the DR system. So it may take a minute. If there's another question, I can answer that while the data, while content server threads spin up. but that is the process. It basically keeps track of the data and will attempt to send it in, until, every configurable amount of time until the content server system is available. Now, the data gets written out here for demonstration purposes. In the event of a disaster, we have the ability to prevent the data from being written out at all until you want it to, or until you're sure that the primary system is up to date. In that case, it just keeps track of the changes in the database, and then once you give the all ahead, the go, it will then write it. Oh, there it is. It just picked up and sent the DR, the object, across to the primary system, and that's how it'll work.
Great. Thank you, Sasha and Matt. Appreciate that. And really, just to kind of finish off, as you've seen today, that designing these kinds of systems, failover solutions, it's got its unique challenges, especially with multi-tiered content server architecture. And we demonstrated today that how Syntergy can assist you with these challenges to really simplify your life as an administrator, or whether you're a business stakeholder. We are open for, you can contact us through our website. We'll follow up with the recording. If you want a detailed demo for your organization, we can set that up. If you want to evaluate the solution, we can set that up. So we'll send you a follow-up email with the recording. But in the meantime, feel free to contact us through our website, and we'll be able to assist you. So thank you for attending. Appreciate your time, and we look forward to working with you in the future.
Thank you, everyone.